substitution. And that's what most of you, I actually saw, substitution was what you were using as you were doing your poster project, right? Substitution is when you replace one variable in an equation with another variable, with something else that you know it was equal to. So you're replacing something, you're substituting in what it was equal for. The other method, Kaylin, we have was what?
Algebraically?
The substitution would be up to this point our algebraic our way. But we want to have another way. What else have we done? The very first systems that we were solving. Graphing. So we have algebraic, which is kind of using the substitution. And there's going to be two algebraic methods we have, and then we have graphing. And when we are graphing only really works well in our systems if you are going to have integer answers, I would say. Okay? If we have integer answers for our x and y, meaning that you see that point of intersection and you don't have any fractions or decimals, right? Because if I have like -2, 1, that's nice to see. But if I have -2.25 and -3 1/4, that's kind of hard to picture graphing and get it exact, okay? So graphing is great when we have integer answers, when our equations are in slope-intercept form, when we are looking at everything kind of being in a nice slope-intercept form, that's when graphing is nice. But when we have huge y-intercepts and our equations are not set up, that is not a good way. So, up to this point we've done substitution. This method is called elimination. To eliminate, it says you'll solve a system by using the elimination method. Eliminate one variable since the sum of the coefficients of y is 0 by adding them. Now, the key thing with elimination is that you are almost always looking for it to be in standard form. Standard form. Please write that down. Standard form, meaning you want the number by itself when we do elimination. When we did substitution, we were trying to get one variable equal to something. So both of these equations are in standard form, and we line up the x's and we line up the y's. And what do you notice as we line up the y's is in front of the y's they have opposite signs and the same coefficient. So they have 5, but the signs are positive and negative, so one's a positive 5 for the coefficient, the other one's a negative 5. Thank you so much. If we add those together, it gives us 0. And so now we are just simply adding our two equations. So 6x plus 2x gives us 8x. 17 plus -9 gives me 8, and x equals 1. Am I done with the problem? No, because I'm still, anytime I solve, looking for an ordered pair. I have just found this answer, x equals 1. I still need to use substitution, and I'm going to now replace the x, and they went to the first equation. They replaced the x with 1, got 2 plus 5y, subtracted 2 from both sides, divided by 5, so they had 5y equals 15, and got y equals 3, and they replace up here with 3. And now if we wanted to make sure that that works, we could check it in that last equation. So if I was going to check it in the last equation, what would I need to write down, Noah, in this equation? I'd put what? 6 times... What is my 6 times 1, that's my x, minus 5 times 3. And the question is this equal to -9? So I have 6 minus 15. Does 6 minus 15 equal -9? Yes. So this is the right answer. Some of you aren't writing your answers instead as an ordered pair. Today we will take a very short quiz. I think it's either 1 or 2 questions. It's going to be on substitution. It's not going to be on this new method. It's on what you did last week or earlier this week. But you have to make sure when you put your answer, you leave it as an ordered pair. Sam?
Once you put in the value, does it matter if you put in the second one or the first one?
Well, since I use the second, or the first one to find y, my guess is if I plugged it in, it's definitely gonna work. So since this is the first equation that I used to find what y was equal to, I wanna use the other equation, because it should work in this one, right? If I replace 3 up here, and I replace the 1, I mean it's gonna work. I definitely know that, because I use this one to solve, so I always wanna use the other one for the check, since I hadn't used that one. If I would have used this equation to find y, then I would have used the first one. Does that make sense? For the check, okay?
What about the X?
Well, I already used the x up here just by adding those two equations together. So it says, which variables should you choose to eliminate? You can eliminate either variables. You're always going to look for the one to eliminate is the variable that has the same coefficient and opposite signs. Same coefficient, opposite signs. And sometimes we have to do some multiplying to get that. Or some subtraction. So, you look at this problem up here. A plus m equals 101. 2.5a plus m equals 164. Which ones have the same coefficient in front of it, the a or the m? The m. What's their coefficients? They're both 1. But if I add those together, they're not eliminating, right? So here's what we said. We said, okay, we can subtract. Now sometimes instead of subtracting, I would like you to think of taking everything times a negative 1. So if I would take, right behind this 164, put times negative 1. And you're actually distributing that to every single thing. Multiplying everything by negative 1 is kind of the same as subtraction. That's going to become a negative 164. That's going to become a negative m. And that's going to become a negative 2.5. Does that make sense to everyone? We multiply everything by a negative. It's kind of the same as subtracting those. I am still going to eliminate the m's, which is nice. Are you writing this, Em? Even if you're not sure you understand, write it so you're with us. So I am now adding my a terms together. Kylie, if I have 1a and negative 2.5a, I end up with 1.5a. My m's are 0, right? There's nothing there. Equals, I'm going to subtract here and I get a negative 63. Lauren, if I'm solving for a at this point, simple equation, go back to the year, what do I need to do?
Divide each side by negative 1.5.
Yep, my coefficient of a is negative 1.5, divide on both sides by negative 1.5. Please do that with your calculator. So we are looking at a. Now, a lot of times if you're given not an x and a y, a lot of times you don't have to write those in an ordered pair for a solution. But if you do have two variables, usually it's alphabetic order. What'd you get, Lauren? 42. Now, if I know a is 42, it's pretty easy to go to the first equation, right? If I go to the first equation and I replace that, I had a plus m equals 101. So Grace, instead of a, I'm going to plug in 42. Plus m equals 101. If I'm solving, AJ, m is going to be equal to, what do I need to do? Minus 42. So 101 minus 42. Did you get it? You can use your calculator, I don't care. 101 minus 42. 59. Let's say 99. Wow, that's a lot. 59. So, I can either leave, because this one's asking me for two variables, I can leave it like this, 42 and 59. I could write it as an ordered pair, 42, 59. I would probably want to put the variables below, because if it's not x and y, you just want to make sure people know which one is which. And if I wanted to do the check for this, Avery, how could I check it?
Substitute it back in.
Okay, which one would you use to check?
The top equation.
Well, I use the top to solve.
Oh, and the bottom.
So tell me, what should I write?
Negative 2.5.
Oh, wait. Go back. When you do that check, always go back to the original, okay? So I know it'd be nice to use this one, but sometimes we'll make stupid, silly mistakes in that first one. So if we go back to the original, now go ahead.
2.5 times 42 plus 59.
Right? And that's what we're gonna check, so put that in your calculator and see if it gives you 164. 2.5 times 42 plus 59. George? You have this? 164? Okay, so we know that these 42 and 59 are the answers. So today when you take the homework quiz and you get your solutions and you're not sure if you did it right, go to the second equation that you didn't use and do the check, okay? All right, so let's look at these two equations. Look at the original ones way up here. Do they have the same variable in front of either number, or number in front of either variable? No. We got -2 with x, we have 7. We have 15 and we have -5. But if I look at 15 and 5, I know that 5, I can multiply it by 3, and this is going to be the easier variable to eliminate because the signs are opposite. And actually, both would be pretty easy to eliminate, but this one you have to multiply both equations. And we'll have to do that soon, but on this one, notice if I take this whole thing times 3, I have to make sure you're distributing so that this becomes a 21. Then the most common mistake is people will get -15 and they will leave this as a 17. And it is just like so easy to do that because you've multiplied the first two and you don't think you have to do the last one. So be really careful when you're writing these and doing the problem that you check, because most of you, if you get it wrong, that would be probably right here is where you're going to make that mistake, is with the 51. So they added them and got 19, x equals 1. They replaced in the second equation, could they have gone to the first one? Sure, but they used the second. In the original, 7 times 1, subtracted 7 from both sides, got -5y, right? They would have had -5y here equals 10, and they divided both sides by -5 to get our solution, -2. The answer that they want to leave, same thing today when you take your quiz, is an ordered pair of 1, -2. And the question is, why multiply by 3 when we are looking at that? And the reason we want to multiply by 3 is that we need the coefficient of y to be the same number, and we need the signs to be opposite. Write that down. Signs opposite. And we already had opposite signs because one was positive and one was negative in the original problem. One was a positive, here was a negative, okay? We could have easily eliminated the x's, and you'll see in this next problem how you can actually have to do both of them, okay? As we are taking a look. So, as we go to that next one, first off, you want to look, are both equations in standard form? Are they both in standard form? No. The second one is, first one is not. So we want to rewrite it so that we have it in standard form. So if I'm going to rewrite this in standard form, I'm going to add 3x to both sides, right? So my first new equation is going to be 3x plus 2y equals what? Equals, we got to add the 1 to both sides. Does that make sense what I did? I added 3x to both sides so that I got it in standard form, and then I added 1, right? I'm going to rewrite that second equation exactly as it is. 4x plus 3y equals -2. If I would start adding these together, nothing cancels, nothing eliminates. And so I need to decide. I notice that in front of both x's, it's 3 and 4. In front of both y's, I have coefficients of 2 and 3. They're both positive. I'm going to have to multiply one equation by a positive number and one by a negative number because I want the signs to be opposite. You could decide at this point. So anyone have a birthday soon? Or just had one? Who just had one? Anyone? Anyone have one soon? All right, so pick for us, Reese. Do you want to eliminate x or y? Because it doesn't matter. X. So if we are eliminating the x's, I need the number in front of x to be the same and the sign to be opposite. What number do 3 and 4 can they both multiply and go into? 12. 3 times 4 is 12. I'm going to take the first one times a positive 4. Everything is going to be multiplied by 4. So I'm going to have 12x. I'm going to have plus 8y equals 4. The second equation, I'm going to multiply every single thing to get 12 again. 3, but I want negative 3 because I want the signs to be opposite so that my x's will eliminate. So I have negative 12x. I'm now going to have minus 9y and plus 6. Negative, negative, negative times a negative gives us positive. Add them together. The x is now eliminated. Don't have them anymore, right? 9y minus, or 8y minus 9y, Ava gives us negative 1y equals 10. So in this case, y equals 10. Negative 10, right? Divide both sides by negative 1. And sometimes your errors will be as easy as that. You will put this down as 10 and you'll go back in and solve it and then you'll check and you can't figure out why it doesn't work. Don't erase everything if you do that. But, so which equation now would you like to use, Addison? First or second? Back in the original one to find x.
The second.
Second one. So we're using the second one because we need to get an answer. We need an xy answer and we've just found negative 10 back here. So we're going to the second one and going 4x plus 3. And instead of using the y here, we are replacing our y with what we know, which is negative 10 equals negative 2. So I have 4x minus 30, or plus a negative 30 if you wanted to write it that way, equals negative 2. We're still just solving basic equations by adding 30 to both sides. 4x equals 28. And x, if I am looking at that, should give us, Ryan, what?
7.
7. So tell me now, how do I make sure I did it right on the quiz today that you're taking after lunch? Someone want to start me and tell me how I need to do my check. Which equation would I want to use, AJ? First one. I'm going to put in 2 times negative 10, right? That's what my y was. Minus 1 equals 3 times negative 7. Negative 29. Second equal negative 21. Is that going to give you on this side negative 20 minus 1? Same solution. Negative 21 equals negative 21. Check. Okay. So when we come back from lunch, I want you to start with adding these because what you will see is that the y's are going to cancel here. Here you have to multiply one equation by a negative 1. So if we are doing that, I know it's almost time, you're going to multiply the first one by a negative 1. So start those 2 so that you can work on these right when we come back. Thank you. We should have, Georgia, what?
8x
Equals, careful, 16. So 48 minus 32. We're going to divide both sides by 8, and x equals 2. Sam, which equation are you using now to find my y? Okay. So you go to the second one. Tell me what I should put in.
3 times 2 plus 6y plus 48.
Okay. So we are going to subtract 6 from both sides, right? And then divide by 6 as I'm looking at that equation. So I subtract 6 from both sides because this is 6. And then I divide by 6. And you have y, Sam, equaling what'd you end up with?
Isn't it 42?
Oh.
42.
Subtracting 6. Oh yeah, thank you. 42. Good job. Divided by 42 and got y equals 7. So, now which equation, Noah? You're on the quiz today. You guys are working. You might get a chance to work together. You are now checking to see that 2, 7 works. What would you do to check it? Use the second equation again? No. We use the second equation to solve for y, so what one do you have to use to do the check? Okay, so in that first equation.
Did you use the top one to solve for x?
We didn't use the top one to solve for x. We just added the two together. We just added them, and we didn't use either one of them to solve for x. We just combined our two equations by adding them. Okay? So, using the first one, tell me what I'm putting down, Noah.
5 times 2 minus 6 times 7 minus
Which, if we're looking at that, 10 minus 42 does equal negative 32, right? 10 minus 42 equals negative 32. Okay? We're not going to check the other ones, but I just want you to be aware that when you take that quiz today, that's how we're looking at that. So in this equation, we're going to multiply that very first one, everything by a negative 1. If I multiply everything by negative 1, the reason I'm doing that is that in front of the x's, I want to eliminate those. And so I need one to be a positive and one to be a negative. So everything changes to the opposite side when you multiply by negative 1. We are now adding the two together. Kaylin, if we add these together, we're going to end up with how many x's? 0x. Add your y's. What are you going to get, Kaylin?
10.
Are you? Did you make this one a negative?
Oh, 0.
0y. And we add our numbers together and we get 5. So we actually have 0 equals 5. What happens when we did substitution or earlier this year when 0 equals a number? False statement, right? Answer should be no solution. This is a false statement. If we have a false statement, our answer is that there are no solutions. If I would have graphed these two, what do I know about the two lines? They would be what? If I were to graph, they would have been parallel lines, right? If I would have graphed, I would have seen two lines. I don't know if their slope would have been positive or negative, but they would be parallel, right? Because there is no solution, okay? So no solution in substitution and elimination is when you get this false statement. And if you were graphing it, it's when you have parallel lines. All right, so let's take a look at this last one. We need the variable in front, the coefficient, to be the same and the signs opposite. Since I already have opposite signs back here for my y's, I'm going to multiply and get the same coefficient. So I'm going to get the first one to be a 6 by multiplying by 2. And I'm going to get the second one to have a 6 in front of y by multiplying everything by 3. And again, you don't have that much room, just like I don't behind here, so we are going to rewrite the first equation, right, and then we'll put the second one right below it. So my new first equation would be, and when you're doing this in your homework, my suggestion is that you just kind of go behind it, but we're going to have 8x plus 6y equals a negative 38. Then we're going to take everything times 3. And again, making sure you do every single thing in the equation. So we have 9x. We're going to have minus 6y. And we're going to have negative 30. And we add our x's together. And we have 17x equals a negative 68. What is our next step if we are looking at solving? Our next step, Kylie, should be to do what? Divide by 17. And we divide by 17, it doesn't come out to be that bad of an answer. What did you get, Kylie? Negative 4. We're not going to do the check on this one. We're just going to get, but if you stop at this point today on the quiz or when you're doing your homework, you've only done half the question. Because remember, anytime I have a system, I have an x, y answer. So I have negative 4. I now need to get y. Maureen, which equation do you want to use?
First.
Okay, so tell me what I should write.
4 parentheses negative 4 plus 3y
And sometimes there's one equation that looks like just really nice and easy, like you don't have to do much multiplying or dividing. Pick that one. This one, they're both the same about. So we have negative 16, right, plus 3y equals negative 19. We are adding 16 to both sides. We're solving 3y equals negative 3, and y is negative 1. If we look at our answer is negative 4, negative 1. Without the parentheses, you are just telling me two numbers, negative 4 and negative 1. This tells me x, this tells me y, okay? So in your homework, you're doing 7 to 25 odd. You do have a book assignment. Your poster needs to be completed for Monday, okay? Let's take a look at a couple of these in your homework. Number 7, please write it down on your paper. Number 7. When you look at number 19, you might decide, I'm going to eliminate the y's, which means I want one to be a negative 12y, right? And I want the other one to be a positive 12y. So you'd say, oh, I'm going to multiply everything here by, and multiply those out, okay? So you're doing through number 25 in your homework, due on Monday, okay? Using elimination, okay? Monday, we're going to do a worksheet that's going to be more with systems using substitution, okay? So the question is, I think maybe what we'll do is on Monday we'll take this quiz and I'll let you work on your homework and we'll do the quiz Monday. So, start on this assignment